Now we'll look at activity number 19.2. That is uh, regarding the uh, conducting of connecting of wires, batteries, and voltmeters correctly. So you need two dry cells, conducting wires, a voltmeter, and ammeter. So look at the pictures or the diagrams which are on the page number 148, and look at the circuit number 1. So circuit number 1, the voltmeter is connected parallelly to the bulb, but the batteries are uh, in the same direction, that they have connected positive ends like this. So normally when you the symbol for batteries is this, right? This is the positive end and this is the negative end. So they have connected the two negative ends together, right? So that won't work, because if you want to connect it, if you want a current to be passed through this circuit, you need to connect the negative end to the positive end, because you, as I mentioned and as I explained earlier, the negative charges flows from the position where the density of negative charges are high to a place where the negative charges are low. So at the positive end, the negative charges are, the density of the negative charges are very low. So if you connect two negative ends, that means on both sides the negative charges are high. So there is the current flow is not there because the charges don't move. So the first circuit is then incorrect, but the voltmeter is connected parallelly and ammeter has been connected in series, so that's correct. In the second circuit, the positive ends are connected together, so that's also wrong. The third circuit is the correct one, where in which the positive end is connected to the negative end, and the ammeter is connected in series, and the voltmeter is connected parallel. So now let's look at the relationship between the current flowing through a conductor and the potential difference across the conductor. So for this you need to do a small activity. So activity 19.3. So you need a nichrome wire coil, right? Nichrome is an alloy, right? You know what are alloys? Alloys are mixing of the metals which are those metals have been formed or made out of mixing two different metals. So nichrome wire coil, voltmeter and ammeter, a rheostat, two dry cells connecting wires, a switch. So you first you have to uh, uh, know what a rheostat is. So look at the diagram or the picture 19.15. So that's a rheostat that is used to vary the current and the potential difference. So you can there's a knob like thing, like this thing. So it's like this. No, the coil is there. There is a knob. So you can move this knob to this end, to this end, right? So when you place a knob here, right? Actually, the current um, flows only not the flows only through this side. That means so this is the rheostat, and there's a wire, conducting wire, which is actually it is a coil. So the knob is there, so you can move this knob either to this side or this side. So if you move this knob to this side, the number of coils will be increased. So the current flows through this coil and passes. If the knob is here, passes like this. You have to connect the circuit like this, right? So the current flows from here to here via this coil. So if the knob is here, the current passes only through this side. It doesn't move in this part of the coil, right? So you can vary the amount of current that flows through the circuit. And when the current is varying, the potential can also be varied. And a symbol for this is for the rheostat like this. These symbols you need to remember. I mean, when you want to draw circuits, and also in the first paper, they will give some of the symbols and ask what is the symbol for the rheostat. Right? So you have to connect the. So you have a nichrome coil, okay, and so this is the rheostat and this is the switch. Ammeter. Here they have connected the voltmeter. So you have to close the switch. And close the switch. And quickly, you should obtain the readings of the voltmeter and the ammeter. And then you have to switch off. Turn off the switch. The reason for quickly turning off the switch is to prevent the temperature of the nichrome coil from rising, right? So because when you as you know, when you pass a current through a wire, it gets heated. So then sometimes you may learn in this lesson there's a um, there's a factor called resistance. So resistance increases. So in order to prevent that, you should quickly turn off the switch. So it is essential to maintain a constant temperature throughout the activity. Otherwise, if the temperature is changing, this resistance is changing, so it will affect your readings. So what you have to do first, you have to switch on the turn on the switch, or you have to close this. switch, and you should get the readings of the voltmeter and the ammeter. Then you have to turn off the switch. So after some time, you have to adjust the rheostat. Uh, Either you can change the knob to this side or to this side, right? So after some time, you have to adjust the rheostat. So for that, you have to close the switch, and after adjusting the rheostat, you have to close the switch and take another set of readings. That means you have to take the ammeter reading and the voltmeter reading. So you have to repeat the above steps to take at least 5 sets of readings. That means you have to change the position of the knob of the rheostat, and you have to take, so if the knob was initially here, uh, in the second instance, um, you have to move it a little bit to this side, and you have to take the voltmeter reading and the ammeter reading. You have to take 5 sets of readings like that. Then from the results you obtain, you have to plot a graph. That means the actually the graph should be voltage against current. Is I ampere. You have to put the units and voltage. Right? So when you plot the graph, you may get a graph like this. Actually, this experiment should be done in the laboratory. So you will get a y equals mx graph. That means you don't have an intercept, right? You don't have an intercept, so it goes through 0. So now this relationship, that means when you increase current, they identify you. No, you can also identify that this voltage increases. So this was first discovered by the German scientist called George Simon Ohm. So he built up a relationship while looking at this graph, and he presented a law called Ohm's law. So we'll look at what is Ohm's law, right? So when the temperature of a conductor remains constant, so that's why we took the first set of readings very quickly, right? Because we have to keep the circuit at constant temperature. When the temperature of a conductor remains constant, the current passing through the conductor is directly proportional to the potential difference. That means when you increase the current, the voltage also increases. That is why it says it is directly proportional. So if it is getting decreased, when you increase the current, if the voltage is getting decreased, then we can say it is inversely proportional to the current. But this is directly proportional. That means when you increase the current, the potential difference also increases. So, but it should be at constant temperature. So, he built up a relationship. I, that means current, is directly proportional to V, that is voltage. So, in order to remove this proportional sign, you can have the equal sign, and you can have a constant, some kind of a constant. When you are removing this proportional sign and putting the equal sign, you need to have a constant. So this constant, we'll look at what it is, right? So then if you take this b to this side, that means I over b is equal to k, the constant. So at any point, if you take the current, so if you say in the first set of readings and the second set of readings, in the first set of readings, if you get a current of 10 amperes, then the voltage is 5 volts. So you divide the current by voltage. So then you get a value. So that value, so if you do the same thing for the fifth set of readings, you should get the same value when you divide these two parameters, right? So if in the first case, if it is like 10 over 5, it should be 2, and in the fifth case, if it is 20 over 10, this should also, these two values should be equal, but this should be at constant temperature. So they define this constant is equal to resistance, right? K is equal to R, resistance. So the this unit of, it's a unit of resistance is ohm. Ohm, this is the sign, right? So the instrument that is used to measure the resistance is called the ohm meter, right? So actually the resistance is the barrier, the barrier the barrier for the current flow. That means when the current is flowing, right? There's a the barrier against that is called resistance. So they, in your syllabus, in your textbooks, they don't have given an exact definition for resistance, but in simply it's the barrier that is for the flowing of current through a circuit. Or else we can say that's the simplest form. Or else in scientifically you can say the resistance is a measure of the opposition to the current flow in an electrical circuit. That means the same thing, the barrier. The barrier to the current flow. And then, so ohm meter is used to measure the resistance. So now I over V is equal to R, right? Actually, I made a mistake here. It can be like this. The K should come here, is equal to B. Then K is equal to B over I, right? So this K is equal to R, simple K. So then it's not I over V, it's V over I. Then if you cross multiply it, you can get V equal IR. So you can do questions. You can find, if you know the resistance, you can find, if you know either the voltage or the current, you can find. If you know the resistance and the current, you can find the voltage. If you know the resistance and the voltage, you can find the current. And if you know the voltage and the current, you can find the resistance. So we'll do a small example. So this is one bulb is connected to 12 volt power supply. A current of 0.5 amperes flows. What is the resistance of the filament of the bulb of that instance? So you have this equation now. V equals IR. The voltage is 12V. Remember to substitute the units, right? I is 0.5 amperes, and you need to find the R. So R is equal to 12 volts, 0.5. Oh, right? Like that. So you can do the exercise number 19.2. You need to substitute those values to this equation. So there are some factors affecting the resistance of a conductor. So the area of the first one is the area of the cross section of the segment of the conductor. That means when you take a wire, conducting wire, if the cross section, the area of the cross section is high, the resistance is low because the current can flow anywhere from this area. But if it is very small, it's hard to move through a small. If you take a big hole and a small hole, so you can easily go through this big hole. Not, when you try to get through the small hole, it's very hard. So likewise, resistance is also, the current can flow easily through a wire that is having a very large cross-sectional area than a very low cross-sectional area. And the length of the wire. So when the length of the wire increases, the resistance increases. Why? You have to move very far. But if it is very short, you can easily move. Right? And the material composition of the conductor. That means out of which metal it is composed of or made out of. The material also influence the resistance.